In this video, we're going to look at radical and imaginary numbers. Our objectives: understand how to simplify radical expressions. Understand how to simplify imaginary numbers. Our vocabulary: a radical number is an expression where the square root symbol stays in the expression. Basically, it's something that doesn't square root perfectly, but we want to write it exactly instead of rounding an answer with a calculator. Imaginary number: number that includes the square root of a negative number. So, when you square root a negative 7, that's an imaginary number. We're going to look at what exactly is that. So we want to start with a basic radical. So we've got the radical of 72. This doesn't come out perfect. It would be a decimal if we used a calculator. So we want to find an exact simplified version of doing this. To do that, we use our factor trees that we learned in elementary. So 72 is divisible by 2, which gives us 36. I like to circle my prime numbers, so 2 is prime. I'm not going to use it anymore. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. So there is my factored version. What we're going to do is we're going to double things up. So 2 times 2 is 4. So we're going to do the square root of 4. We've got 3 times 3 is 9. We're going to do the square root of 9. And whatever is left is going to go in our last square root, anything that doesn't double up. So here it's going to be 2. Then we're going to do the square roots that we can. Square root of 4 is 2. Square root of 9 is 3. And then square root of 2 is square root of 2. 2 times 3 is 6. With square root of 2, so 6 times the square root of 2 is the same as the square root of 72. Let's try it with 56 now. So we got 28. Okay, so we have a pair right there, so we're going to get square root. 2 times 2 is 4. And then there's nothing else that doubles up, so we're going to get square root of 2 times 7, and we're going to put both of those in the same one. And we can't square root this one. Square root of 4 is 2, and then we've got the square root. We multiply these together. 2 and 7 makes 14, so we've got 2 times the square root of 14 is the same as the square root of 56. This is simplifying our radicals. Okay, let's do some math with radicals. First thing is a little subtraction. All we have to do is actually treat it like terms. So square roots have to be the same so that they can be combined. So 3 and 5, so we've got 3 minus 5 is negative 2. We've got 4, since this has a square root of 3 and this has a square root of 3, we can combine these. This would have a 1 in front of it. Treat the square roots kind of like variables. So this is positive 4 minus 1 is positive 3, and we keep the square root of 3. We've simplified a little. Okay, here, square root 8, square root 2 cannot be combined, but let's see if we can simplify square root of 8. So we've got 2 square root of 2, and bring down our plus 3 square root 2. They both have square root of 2. we can combine them. 2 plus 3 is 5 square root 2. And our last one, kind of the same vein. So we've got square root 4 square root 3, which is going to give us 2 square root 3 plus 5 square root 2 plus 5 square root 3. Okay, so square root 3's can be added. So 2 and 5 make 7 square root 3. Square root 2 can't be added with it, so it just comes down. And there's our radical there. Now let's look at imaginary numbers. Imaginary numbers go off of basically the same premise, except we're going to put an I next to them, identifying them as imaginary. So this is going to turn into the square root of 100 I, and the I stands for imaginary. So the square root of 100 is 10, and we have our I. So this is an imaginary 10. Okay, we can do that also with numbers that don't square root perfectly. Put the I next to it. Okay, double up. We've got square root 4, square root 2 times 3. It's going to be 2 square root 6. Don't forget your I. 2 square root 6I. Alright, let's do a little bit more math with imaginary numbers. These already have the I's in them. Think about the I like an X. I's can only go with other I's. So 3 plus 6 is 9. Negative 4 plus positive 2 is negative 2, and the I's are what allow us to put them together. So we have 9 minus 2I. Same thing here, just with subtraction. 7 minus 5 is 2. Positive 5 minus negative 3, so 5 minus negative 3 would be positive 8, and the I's allowed us to put them together. The last version I'm going to show you is a little bit strange, but I want you to notice something. We have multiplication here, so we can do a Punnett square with the imaginary numbers. So we're going to go 2 negative 3I on the left side, and 4 positive 2I on the top, and then we fill in our box. So 8, this would be negative 12I. Notice the I's are acting just like X's. 4I, and this would be negative 6I squared. Then we would rewrite it. 8 minus 8I minus 6I squared. Now, special thing is, I squared is the same as negative 1. So we can go 8 minus 8I minus 6 times negative 1. 6 times negative 1, or negative 6 times negative 1 is positive 6. 8I, 8 there. And then the 8 and the 6 become 14 minus 8I. Now this last step from here down is new and kind of different. If you don't understand that, that's okay. At the very least, you should be able to get it there. Alright, this has been looking at radicals and imaginary numbers. Make sure that if you missed anything or didn't get something, that you pause, rewind, and rewatch it, and then bring any questions to class. Thank you.